All right, section 8.3 is, we're talking about graphs of sinusoidal functions. So that's something, that's probably a new term for most of you. Sinusoidal, the root of this word is sine, okay? And soidal is sort of like a descriptive, so it's kind of like something that looks like a sine graph. That's basically what it is, and you'll see that definition down here in your textbook. Okay, so I will be referring to that. If you want to write it down, you can. If you need it in your notes or want it in your notes, go ahead. But it is right there in the textbook. A sinusoidal function is any periodic function. So we talked about that last section. Something that it repeats, right? It's a kind of a regular repeated motion. And if it looks at all like a sine graph, okay, and of course here there's a section of this that's exactly a sine graph. Starting here, it goes up, down, back up to the middle, right? So that's a sine graph shape. So that's what a sinusoidal function is. So a sine graph, y equals sine x, is sinusoidal, and y equals cos x is sinusoidal, okay? Even though it's a cosine, it's still a sine-like graph. Because if you recall back here in 8.2, right here, that sine and cos are the exact same shape. But a cos technically would be shifted 90 degrees or pi over 2 radians one way or the other. All right? So they're both sinusoidal. All right. Now that we got that out of the way, we talked about amplitude, right? Period length. We talked about midline last section. So this section here, we're going to explore more of the graphs of these functions and what the graphs mean in real life situations. So let's just get some practice here. Let's take a look at this introduction here. The Star of Nanchang Ferris wheel ride. Has anyone been on that Ferris wheel ride? Any hands there? No? Okay. I haven't either, no. But it's a pretty big Ferris wheel, and I think there's a picture on the next page here. It's a pretty big Ferris wheel. This looks like it. Look at that. That's right. Those are clouds up there, I think. Anyways, look at those little carriers there, little seats. That is one huge Ferris wheel, okay? So let's talk about this one. This is the graph for height. It would be height of the Ferris wheel versus time. So in a graph like this, we're going to get a whole bunch of information just from this graph about the Ferris wheel. For example, let's take a look. How can you tell from Simone's graph, so Simone made this graph, that the lowest part of the Ferris wheel is 2 meters off the ground? Okay, so the Ferris wheel comes down and the lowest part of it is 2 meters above the ground. How can you tell from this graph? Anybody? It says beside the dots, okay? So be more specific. This dot here? Okay, at the bottom. So it says it has bracket 0, 2 bracket. So you're saying it says there. Now, can you expand on that? Like, what do you mean it says there? Because I just see 0, 2. What does that mean? The x is 0 and the y? No, you're right. The x is 0 and y is 2. You're absolutely right. So how do you know from that, though? I'm just trying to get at how do you know from that that the Ferris wheel is 2 meters off the ground now? What part about that? Y is height, x is time. So if the y value for this point, which appears to be on all of these the lowest point, right? This appears to be the lowest point. So y is 2 on all of those. So yeah, so from the graph, so I know you knew it, but I'm just trying to get you to verbalize every detail, okay? So that you and everybody else will know exactly what's going on. And like I say, on a test, if I ask you this question and you say the graph, it just says on the graph, you're not going to get any points, right? So you have to tell me what part of the graph says that it's 2 meters off the ground. So just to summarize what Caleb said here, this 2 right here is the y value for this point. This point represents the lowest point that this Ferris wheel would reach. And because y is 2, that's the height in meters above the ground. So the lowest part is this value, 2 meters above the ground. Awesome, okay? Let's keep going. Determine the maximum value of the graph. So if you look at this graph, what is the maximum value? Just one number answer, what is it? 160, very good. Now you don't look here, don't look there. What you do is you look at the point, that's the highest point, and you say, what is my y value? That's the maximum value, it's 160. If this graph went up to, if it said 170 up there, you wouldn't read that number. You would read the number on the graph. Okay? Yes, the maximum value is 160. Okay? So what is the height of the Ferris wheel? How high above the ground does the Ferris wheel reach? 160 meters. That's a lot of feet, right? That's a long ways off the ground. We're on the 4th floor of this building right now, and that window ledge is just under 12 meters. 12. So this thing is 160 meters. Okay, so like, more than 10 times the size of this building. Probably about 10 times the size of this building. Yeah. Okay. So that's pretty high. All right. What's next here? Determine the range of the graph. Okay, so do you guys remember domain and range? Range is all the values, the y values, that are encompassed in the graph. So what is the range? It goes from, what's the lowest value of y? It goes from 2 all the way to 160, just like we said. So how would you write that? Okay, so for our example here, the range equals, you do these kind of braces, funny brackets, and you can just simply go like this for a range. If there's a lower value, you put that first. Okay? If there's an upper value, you put that at the end. Now you put the variable, so that's the y variable, in the middle. And then you do these less than signs here. If the range includes this number, so if 2 is actually part of the range, which it is, then you would do or equal to as well. See? So now we're saying that y, if you read from the middle, y is greater than or equal to 2. At the same time, y is less than or equal to 160. So it's like it's sandwiched in between there. Does it make sense? And then like this. Okay? You don't have to do this. I know in the back of the book they kind of do something like this, y such that, and then they do all this, and then they go comma, y's element all around. You don't have to do this and this, okay? Just put this in the middle, that's all I'm looking for. Okay? Just for now, just to simplify things for you. Okay, good? Questions there? Or everybody get that? Alright. So amplitude of the graph. Remember what amplitude is? 8.2 amplitude right here. So amplitude is from the middle to the top, or it's from the maximum point to the minimum point, that whole distance divided by 2. So that might be easier for us to actually do, right? Max minus min divided by 2. Oops. So the amplitude, the max minus min, so 160 minus 2 is 158. What's half of 158? It's half 158. 75 is 150. Add 4 to that. 79, that makes sense. So we got about 79 meters is from the middle of the graph to the top. Okay, am I doing my mental math right today? Yeah? 158 divided by 2? 79. Okay. Amplitude. So what does this value represent? What does the amplitude of the graph represent? We look at that picture there. Sorry? Right here? The middle of it? Okay. It has something to do with that. Yes. You actually, that's the answer. Where this is, the height off the ground, is actually the answer, I think, to the next question. So the amplitude would be the distance from the middle to the very top, or from the middle to the very bottom. So it has something to do with the middle of the Ferris wheel. You want to add to that, or anybody else want to add to that? The amplitude represents the radius. Good, yeah. So that's the distance from the middle to the outside edge, anywhere on the outside edge. So the amplitude is actually the radius of this big circle. Does that make sense? Yeah, so the amplitude is the radius. So it's 79 meters from the middle to the very outer edge of this Ferris wheel. Okay, good, we're getting it. Now, back to you again. The equation of the midline, what does this value represent? And the equation of the midline would be y equals this height that is the very center. of the Ferris wheel. Okay. So what is the equation of the midline? We know what the amplitude is. What's the equation of the midline? Y equals what? Is it y equals 79? Amplitude? Tricky question, actually. Let me just copy this so I can write on it. It's not actually y equals 79. So why is that? Because the amplitude is the distance from the top down to the middle, or from the bottom of the graph all the way up to the middle. So if this is 79, can you read that yellow? Not very well. If this is 79, this distance here, okay, it's pretty difficult, then the equation of the midline is y equals what? And actually, I'll draw this a little bit more accurate. From here, it's right about there. So it's y equals 81. Wow, something funny there. Does that make sense? So the amplitude, so you have to add the amplitude from the very bottom point. That's your equation. Or subtract it from the very top. Yes? Okay. Just give me a shake your head if you don't get that. Okay, I see one shake. Nod your head if you understand that. Okay, I'm seeing a lot of nods. So that's good. But for the one shake that I saw, okay, the amplitude is 79. So again, you start from the very bottom point, which is actually y equals 2. See that? And then you add 79 to that to get to the equation of the midline. So it's 2 plus 79 is 81. Okay? All right. Okay. You can ask me again later if you don't get that. All right, we're almost done here. This example, this has been good. Okay, determine the period of the graph. Explain your method. All right, the period of the graph. How are we going to find the period of the graph, or the period length? And the period is, of course, the horizontal, right? So we're actually looking at the distance, the horizontal distance. So how do we find that? You don't have to have an answer, but how do we find the period here? Anybody? What's the definition of the period? You remember from last day? It's the time. In this case, it's the time. Okay. So or the x, the difference in x values from the beginning of the cycle to the end of the cycle, or from the from one point in anywhere in the cycle to the next corresponding point of the cycle. So really, it's how long, in this case, how long it takes for one complete cycle. If I start here, right, that's at 0, time equals 0, then this whole thing goes up and down and back to the same point here in how many minutes? 30 minutes. So the period is 30 minutes. Now, let's just back up a little bit here. So I'll erase that line. Another easy way to do that is to say, well, I'm going to pick this point. I know this is the maximum point, and it's at 15. This is the next maximum point. That's at 45. So when you see the next corresponding point, or the next identical point in the cycle, 15 to 45. So subtract those, you get 30. So the period, or the period length, is 30 minutes. So what does that mean if you're a person on the Ferris wheel? What does that mean for you? It means you better go to the bathroom before you get on, A, right? It means that if the Ferris wheel is moving the whole time and not stopping, and it's going to stop to let people on and off, it doesn't look like this is accounting for that, right? Because if it were going to stop for people to get on and off, it would kind of look more like this, right? Stop, up, stop. Like that's what it would look more like. So this is continuous. If that Ferris wheel is moving the whole time, that means it takes you a half an hour from the bottom point, or when you get on, it's moving the whole time. It takes you a half an hour to get back down to the bottom. So that's a pretty big Ferris wheel going fairly slow, taking a long time. Make sense? Yeah? Questions about that? No questions? Okay. All right, were there any more questions on this little, let's see, period, explain your method. Okay, we did that. What length of time is needed for the star of Nan Chang to make one full revolution? Okay, well, one full revolution. That's going to be one time around to the very top again, or from the bottom to the bottom, so that's half an hour, I guess, right? How long does it take to get to the top of the Ferris wheel from the bottom? I guess that would be exactly half of the period length, right? So it looks like here, 0 to 15 minutes, or half of 30. Good? All right. Okay, that is, yeah, that's, if you can understand that, all of those pieces, amplitude, period length, time it takes for one revolution, that's huge. That's kind of the main example for this section. So if you understand all that and what a sinusoidal function is, you're in really good shape. Okay, one more example of just talking about the midline, okay? Y equals. Now you can look at this and you can guess, okay, what's kind of the middle? I'm guessing it's maybe 2 or 3 or somewhere around here. You can guess, but don't guess, okay? What's the surefire way of finding the equation of the midline? Well, if we can find the amplitude, you can add that to the bottom or subtract it from the top. But a more straightforward way would look something like this. Okay, so let's go back to our notes and put this one on there. Equation of the midline, okay? So what happens if you take the maximum value that you see, which is 7 here, right? And the minimum value, which is like -3. How do you find the very middle point between these two? How do you find an average between any two numbers? Now we're thinking about an average. How do you find the average? Yes, add them and divide by 2. So the average value would be 7 plus -3 divided by 2. What does that give you? That's 7 minus 3 is 4 over 2 is 2. So if you look at that, number 2, that's the average between those two numbers. That is the equation of the midline. Okay? So y equals 2 is the equation of the midline. So once you get that average value, this is the equation of the midline. The amplitude is different, right? The amplitude is not the equation of the midline. Here we added the amplitude is the maximum value. How do you find the amplitude? The maximum value. Do we just find the average again, or what did we do? Maximum, okay, minus the minimum. And then do we divide that by 2? Remember? Maybe? Okay, let's try it. So what is this? This is 7 minus -3, that's 7 plus 2, that's 10 over 2. That is 5. So does that make sense that the amplitude is 5? Let's count. 1, 2, 3, 4, 5. That gets us to the midline, so yeah. So that's a good thing for you guys to remember. The equation of the midline is the average value. Y equals the average value. And the amplitude, and I'll just rewrite over that, I guess. Amplitude is it is half of the range, really. That's half of the range. Okay. Okay. Any questions? Okay. Here's the summary for the section. So maybe just give that a read over, and I'll give you your assignments here in a minute.